All right, in this problem, we have a circular plane with a charge of plus 50 microcoulombs, and it's lying above the ground. And if a charged particle of 2 microcoulombs is placed 4 centimeters above the plane, considering that this plane has a meter of 9 pi meters squared, will the particle float if its mass is 0.0203 kilograms? So we need to consider all the forces acting on this particle. And so that would be the electrostatic force and the gravitational force. So first, for the electrostatic force, we need to figure out the electric field acting on the particle by the circular plane. So for that, we'll use our approximation. Since we are close to the surface, the particle is close to the surface of the plane and far from its edges. So we'll use this approximation, the total charge over the area, so 50 microcoulombs over 9 pi, and then times 2 epsilon naught. And that evaluates to 99,863 newtons per coulomb. So from that, we can calculate the electrostatic force, which is just our charge, in this case, charge of a particle, 2 microcoulombs times the electric field. And that evaluates to 0.199 newtons approximately. Now for gravitational force, that is acting obviously in the opposite direction. And that's negative mass times g, the force of gravity, or the acceleration of gravity constant. So that will be negative 0.0203, our mass, times 9.8, which approximately evaluates to negative 0.199 newtons. So since our two forces, which are acting in opposite directions, both on this particle, means that they will cancel out and the particle will float in the air in the same place.